Number 4 says, if 1.951 grams of barium chloride, XH2O, right, so this is our hydrate problem, yields 1.864 grams of anhydrous BaSO4, no water. That's what anhydrous means. After treatment with excess sulfuric acid, what is the value of X in the formula of BaCl2XH2O? Round to the nearest whole number. All right, so this is our hydrate question, right? So remember, what we really have here is we have a molecule of BaCl2. I'll just call it W for water, with some amount of waters around it. I'm putting arbitrary 4 waters, but I don't really know the answer, so we're going to figure it out now. That's the whole point. We want to know for every 1 mole of our salt, how many moles of water I have. That's the whole point of this problem. So let's figure it out. Well, we know first off, we started with BaCl2, and then we added sulfuric acid, which was in excess, which is really important because that lets us know that since we added excess sulfuric acid, the limiting reactant was our barium, right? So they told me we ended up getting 1.864 grams of BaSO4. That's after I had my BaCl2, so I had, we'll say, BaCl2, and I threw in some sulfuric acid, so H2SO4. And I made BaSO4. Our limiting reactant here must have been the barium, because they told me I had excess of this. I had enough of this so that this would run out first. And this, with the sulfate, I ended up making my barium sulfate. So that's where that came from. We're just precipitating out the barium. So like I said, so if I know my barium is my limiting reactant, that's my link to this barium sulfate. So you always have to be thinking about the number that they give you, what's the link back to the thing that I really want. So I wanted barium chloride, my link between barium sulfate and barium chloride is my barium. So if I had 1.864 grams of barium sulfate, we can do some stoichiometry to see how many grams of barium I had. So I know, pull up the numbers here. So I know there are 233.4 grams per 1 mole of BaSO4. I also know that for every 1 mole of BaSO4, I have 1 mole of barium, right? Mole-mole ratio. For every 1 mole of barium sulfate, I have 1 mole of barium. Okay, so that cancels out my moles of barium sulfate. Now I'm in moles of barium. I also know that for every 1 mole of barium, I have 1 mole of barium chloride, right? Because again, for every 1 mole of barium, I have 1 mole of barium chloride. Now, one step further, I know for every 1 mole barium chloride, I have 208.1 grams. So remember, when we're thinking about the hydrate problem, what we should be thinking is, I want the moles of the, so really what we're looking for is mole of BaCl2 and mole of H2O. That's what I'm looking for. That's what I want. Because we're going to go just like we did for that empirical formula question for number 2. We're just going to divide by the smallest one, which is always going to be the barium chloride, giving me one of these and X amount of H2O. So this is what we're looking for. Always when you're doing a hydrate problem, try to be doing that. So this is going to give me grams of barium chloride. So I know I'm wanting moles, but I actually have to go to grams first. We're going to see now why. So this number right here is going to be, so we canceled out moles of barium chloride. We're in grams of barium chloride now. And that's going to give us 1.66 grams of barium chloride. Okay. Well, the question told us that there was 1.951 grams of barium chloride with the water. So if this is just my barium chloride, 1.951 minus 1.66 should be my water, right? That number is going to be 0.289 grams H2O. Okay, so now we have mostly everything we need to finish off this problem. So I have 1.66 grams of barium chloride, and I have 0.289 grams of H2O. So we're going to go to moles, just like we did for number 2. So I know there's 1 mole of barium chloride. There is 208.1 grams, right, just like how we had it up here. And I know for every mole of water, 18.016 grams. That's probably a good molecular weight to memorize. You're going to be using water a lot in this class. So these numbers are going to give you 0.0079 mole BaCl2 and 0.016 mole H2O. Now this is really important. If you see here, my moles of water is bigger than my moles of barium chloride. If you get bigger moles of barium chloride, you messed up. Because the whole point of this is, now I'm going to divide by the smallest one, like we did for number 2. I'm going to divide by 0.0079, divide by 0.0079. So this should go to 1, which is like I told you I wanted it, right? I wanted 1 mole of barium chloride for X amount of moles of water. And now this guy right here is going to be 0.016 divided by 0.0079 will give you the answer, which is 2. So I have 2 moles of water for every 1 mole of barium chloride. And that is answer choice number 2. Oh, I'm not going to circle it again, but yep, that's answer choice number 2, and that's number 4.
The Teaching Center, UF's Learning Resource Center.